So today we are going to start the new, second phase of new chapter 3, Assembler Directives and Assembly Language Programming. In fact, we have already, I told you earlier that as far as this chapter is concerned, this chapter has been divided into two sections. One is program control instructions, and second is assembler directives and assembly language programming. The first part we have already finished. So far, as far as microprocessor is concerned, so far in first chapter we have discussed all hardware aspect. In second and first part of third chapter, we have discussed software aspect of 8086 microprocessor. It means all instructions we have discussed, right? Now, because since this is programming, since you need to get yourself versed with well versed with 8086 programming, you need to understand what is assembler language, assembly language programming. And if you really want to understand assembly language programming, you need to understand assembler directives. And therefore, to begin with today, we are going to discuss all assembler directives, and then if possible, today it may not be possible, but it maybe in next lecture we are going to have some assembly language programming practice. So what is assembler directives? Now, first of all, we need to understand what is assembler. You must be well aware of compiler. You must have seen, you must be knowing rather what is compiler means. Compiler is a software program which will convert high level language into machine language. Okay, compiler is the software program, is kind of software which will convert high level language into machine language. Assembler is again a computer program for translating assembly language, essentially the mnemonic representation, because assembly language basically is a combination of mnemonics. Mnemonics, I told you earlier what the meaning of mnemonics is, and again I will quote you example too, like MOV AL comma BL. So this MOV AL comma BL will be referred as mnemonics. So assembly language programming essentially will be consisting of all mnemonics. So assembler will essentially convert those mnemonics representation of machine language into object code. Okay, this is very important, and it is a program which will allow the programmer to write, execute, debug assembly language program, and to examine the content of register and memory. It can also be used to run a program on instruction, one instruction at a time. What does it mean? It means, we know, like whenever you will be executing program on 8086 microprocessor kit, you cannot execute program instruction one by one. Like if the program consisting of 10 lines, so you need to execute the entire program at a time. So you cannot execute one program, one instruction at a time. Whereas if you are having assembler, then assembler will help you to execute one instruction at a time. You can see, like that is why it is mentioned that this assembler will allow programmer to write the program, to execute the program, to debug. Debug means, like, if something wrong in the programming, so that program can be debug. That can be easily debugging means making correction in the program, right? So that also can be done. This assembler will allow you to do all these activities: writing program, execution of program, debugging a program, and most importantly, you will be able to examine the content of register as well as memory location. And that is why I said last statement is, it can also be used to run program one instruction at a time. It means, like, if you are, let us say, MOV AL comma BL. What is the meaning of this MOV AL comma BL? The content of BL is going to be transferred to AL. So you can see, like, how the data is being transferred. Before execution, you can see the content of AL. After execution, you can see the content of AL. This is the beauty of this assembler, which will not, you will not be able to do this by using if you are executing program on machine language or 8086 microprocessor kit. Now ALP contains two type of statements. Okay, ALP means assembly language programming, consisting of two type of statements. One is called as instruction. What is instruction? Instruction, these are translated into machine code. instructions are going to be translated into machine code. So the programming will be having instructions which will be converted into machine code, and at the same time it will be having some directives as well. Directives, these are not translated into machine code. Directives are not going to be translated into machine code. It gives direction to the assembler to perform the task of assembly process. Assembler support directives for data definition, segment organization, procedure, micro definition, and etc. What does it mean? It means, like, whenever we are talking about assembly language programming, there would be instructions. What instructions will be doing? Instruction will be useful for reaching to a destination. Reaching to a destination means, like, if you want to write a program to add two numbers, right? So you will be having some instructions. Those instructions will be useful for getting addition of two numbers. That's it, right? But and then those instructions are going to be, whenever we are doing whenever you will be assembling program, it means assembler will convert those instructions into machine language program. However, if you really want to do the addition, you need to give some directives to the assembler as well. Directives means what? Like, once you get the addition, where the data need to be stored, right? Where the process data can be stored, where the raw data can be stored. All those things can be given by using some assembler directives, and that is why we need to discuss. We need to study what are those assembler directives. That is why it is mentioned. It gives the direction to the assembler, because these directives are mainly meant for giving some direction to the assembler to perform task of assembly process. Perform task of assembly process means, you can see the example. Assembler support directives for data definition. It means, like, you need to define data, you need to define segment, because for example, if you want to enter raw data, that raw data need to be stored in data segment, right? Once that raw data is received by the processor, again you are going to have process data. Then you need to tell processor that where that process data can be stored, what should be the destination. All those directives, all those instructions can be given in the form of directives, and therefore these directives are not going to be translated into machine code, because these are not mnemonics. These are some directions. Those directions are these are going to be some kind of direction to the microprocessor, or to the assembler rather, whenever it is going through the assembly process. Okay. Now, what are the examples of directives? MASM is one of the example. MASM means Microsoft Assembler. TASM means Turbo Assembler. FASM means Flat Assembler. NASM means Net-Wide Assembler. So these are three, 1, 2, 3, 4, 5 different kinds of assembler available in the market. We are going to use TASM assembler in our laboratory for performing experiment. So let me tell you again, assembly language program जो होता है उसमें दो type के there will be two section. One section means instruction, जिनको हमें क्या करना है, the assembler is going to convert those instruction into machine language, and directives क्या होंगे? Directives are going to be a kind of directions. मतलब माइक्रोप्रोसेसर असेंबलर जो असेंबली लैंग्वेज का कन्वर्जन जो मशीन लैंग्वेज में करेगा, मेमोरी मैपिंग होगी, that can be directed, that kind of direction can be provided by the directives. Then what are the assembler directives? Let us see one by one. So instruction to the assembler regarding program which is being instruction. What are the assembler directives? These are a kind of instructions to the assembler. Okay, because you see, instructions are going to be instructions. I mean mnemonics, MOV, AL, BL. These are kind of 8086. We are calling it as a 8086 instruction, because those instructions are going to provide some direction to the 8086 microprocessor, whereas assembler directives are going to be a kind of instruction for assembler regarding the program which is being executed. Control the what assembler will do. It will also control the generation of machine code and organization of program, but no machine codes are generated for assembler directives. As I mentioned earlier, assembler directives cannot be converted into machine language, right? Because there is no question of converging those assembler directives into machine language. Rather, these assembler directives would be a kind of direction for the assembler whenever the program is going to be executed. And therefore, it is called as a pseudo instruction. Pseudo instruction means these are not real instructions, because whenever we are talking about instructions, those instructions need to be converted into machine code. But these are not going to convert into machine code, as I mentioned earlier, and therefore these are called as pseudo instructions. It is used to specify the start and end of the program, because whenever we are talking about programming, structuring, you need to have the indicate the start of the program, end of the program, attach value to the variable. You can by using assembler directives, you can attach value to the variable, because as far as 8086 microprocessor programming is concerned, we have got very limited number of registers. Like we have got only 4 8-bit 16-bit registers and only 8 8-bit general purpose registers. Whereas if you are using assembly language programming, and if you are using assembler, then you can use many other variables, just like high level language. That is why assembly language stands in between machine language and high level language. So you can, if you really want to do that, you can assign some some value, some data to the variables. It can allocate storage location to input and output data. As I mentioned earlier, input data means raw data, I mean to say, and output data means the processed data. So assembler directive is going to provide some sort of direction to for storage location as well. So it is going to it will use to allocate storage location for input and output data. It also define start and end of the segment, procedure, and macros as well, right? Segment means like procedure and segment. These are a kind of logical program, I would say. It is sub program of the main program, right? So you need to mention, like if you are having 3 different procedure in one program, okay, 3 different procedure in one program, then you need to indicate what is the start and what is the end of that particular procedure. Similarly, there are in the assembly language programming, you can have data segment, you can have code segment, you can have stack segment. So whenever we are talking about this segment, you need to mention, we need to indicate what is the start of that segment and what is the end of the statement. That can be done by using assembler directives only. And these are some of the assembler directives. First of those is DB. Okay, DB means defined byte. DB stands for defined byte. What is the purpose? Purpose is it is define a byte type variable. It is define a byte type variable. What does it mean? It means it reserves specific amount of memory location to each variable. And what are the range? You can see if it is unsigned value, then you can have 00 to FF. If you are talking about sign and positive value, 00 to 7F is going to be considered as a positive values, and 80 to FF is going to consider as a negative value, because MSB is going to consider as a sign bit. If you consider MSB sign bit for 00 up to 7F, your MSB is going to be 0, and that is why this is going to consider as a positive values. And 80 to FF, of course, 80 again we can call it as a 0 to minus 7F. 0 to minus 7F, that will be considered as a negative values, but as a whole we can consider as a 80 to FF for negative values. This is one of the example. You can see list db 7f comma 42h comma 35h. What does this means? This means list is the variable. Okay, list is the variable, one-dimensional variable rather, having 3 different elements. List is the variable having one-dimensional variable having 3 different elements. So what we are doing, define byte means we are going to define list a kind of byte type variable, and 3 different values are going to be allocated to list variable. Okay, so as I mentioned earlier, assembler, this is assembler directive. One of the DB is one of the assembler directive. What is the purpose of the assembler directive? The purpose of this assembler directive is to declare variable which can allocate byte 1 byte data, which can allocate 1 byte data. Like for example, here list, this is the format, right? List db 7f 42h 42h 35h. It means we are defining a list as a byte type variable. and at the same time we are assigning 3 different data to list. It means this is one dimensional variable having 3 data elements. Okay. To be more like you can see here, this is more explanation about the same, like define byte. It defines byte type variable, direct assembler to reserve 1 byte of memory and initialize that byte with the specified value. It can be defined single or multiple variable. Right? Now example, more example. This was one of the example. These are this is more. There are more examples of the same directive. Temperature dB10. Now here we are defining temperature as a byte type variable, and we are assigning 10 data to the temperature, 1 byte data. Temperature dB question mark means what? We are initializing temperature as a defining temperature as a byte type variable. Question mark means no data has been allocated. We are keeping it blank. Okay. 10 temperature dB 10, 20, 30, 40, 50. It means we are defining temperature here as a byte type variable, but byte type one dimensional variable in which 5 element rather, 10, 20, 30, 40 are going to be allocated to this variable. Similarly here temperature dB 5 question marks. It means there would be 5 memory spaces allocated, and in which 1 byte of data can be stored, but we are going to keep it blank, because question mark means this is going to be blank. Now temperature dB 100 DUP. What does this means? This means this temperature is going to be one dimensional variable having 100 element. How many element? Having 100 element. One dimensional variable with 100 element, and all are going to be uninitialized. Question mark means uninitialized. No data is going to be stored. Now let us consider second assembler directive, DW. DW stands for define word. DW stands for define word. So define word means 16-bit data. Word means 16-bit data. So it reserves 2 consecutive memory locations to each variable, because one memory location can we can store 1 byte of data to one memory location. We here, because this is word type, define word type, right? DW means define word. It means we are going to define the variable of word type, and 16 bit data can be allocated, and this is the range. You can see, since it is 16 bit data, 00000 to FFFF is going to be unsigned value. As far as positive values are concerned, 0000 to 7FFF, and negative value 80 to FFFF for this is negative value. Right? And this is one of the example. A list DW 6512H, 0F2511H, CDE2H. Okay, so this means that a list is going to be a word type variable, and it is going to be one dimensional, and 3 elements, these 3 data items are going to be allocated to this a list one dimensional variable. Now again more information about DW. DW, as I mentioned earlier, it is defined word. It defines a word type variable, direct the assembler to reserve 2 byte of memory, and initialize those byte with the specified values. It can be defined single or multiple variable. Like again, few more examples. Temperature DW1234H. It means this temperature is going to be word type variable, and here this data is going to be initialized to or assigned to temperature variable. Now here, now there are 3 data items. What does it mean? Now this is going to be considered as a one dimensional variable having 3 elements, and all those 3 elements are going to be initialized to temperature. Here temperature DW2 DUP0. What does this means? This means this temperature is going to be one dimensional variable having 2 data items, and all the data items are going to be 0. So we are going to initialize it as a 0. Friend, after 10 minutes, this link is going to be terminated. You have to rejoin again by using same link. Similarly, we have got DD. DD means define double word. So DB define byte, DW define word, DD means define double word. Double word means 4 byte of information. Okay, so this directive is going to result. This is going to be used to define double word type variable. Double word means 4-byte variable, right? So it will direct assembler to reserve 4 byte of memory and initialize those bytes with the specified values. Okay. Now, for example, temperature DD 1, 2, 3, 4, 5, 6, 7, 8. So this is a kind of, you see, 4-byte, right? 1, 2 is 1 byte, 3, 4 is second byte, 5, 6 is third byte, and 7, 8 is fourth byte. So this is 4-byte variable. This 4-byte data is going to be assigned to temperature. Here, temperature DD 5 DU 0. What does this means? It means this is going to be the one-dimensional variable having 5 data items, and all data items are going to, all locations, 5 different locations are going to be initialized with 0. Okay, because here, if it is question mark, it means it is uninitialized. If it is 0, means it is initialized with 0. Similarly, we are having DQ. DQ means define quad word. DQ means define quad word. So quad word means it's going to be double of 4-byte, means it is going to be 8-byte. So it means whenever DQ is used, we are going to reserve. I would request all the student to mute their mic. Please mute your mic. So DQ stands for define quad word. So it defines a quad word means 8-byte. Quad word means, you see, word means a 16-bit. One word means 16-bit. Here double word means 32-bit. Here quad word means 4-word. 4-word means obviously 8-byte, right? So this is going to use to define 8-byte type variable. So it will direct the assembler to reserve 8-byte of memory and initialize those bytes with the specified values. Okay, like for example, temperature DQ 1, 2, 3, 4, 5, 6, 7, 8. And again, like again one, because this is, you see, this is because we want 8-byte. This is not complete 8-byte. This is only 4-byte. 1, 2, 1 byte, 3, 4, second byte. This is third and this is fourth, right? So this is going to be only 4-byte. So there will be again 1, 2, 3, 4, 5, 6, 7, 8 here. Okay, that is missing here, unfortunately. I forgot to write that. So okay. So temperature DQ 1, 2, 3, 4, 5, 6, 7, 8. This is 4-byte. Again 1, 2, 3, 4, 5, 6, 7, 5, 8. So all these data can be, all this 8-byte data can be allocated to temperature. Now, what is this? Temperature DQ5 DUP0 means this is going to be one-dimensional variable having 5 data items, and all data items are going to be 0. It's going to be initialized with 0 value. So this is all about DQ. And next is DT. DT means define 10-byte. So define 10-byte, like this is 8-byte. This is going to be DT stands for 10-byte. So when whatever variable you are going, format is going to be the same. Whatever variable you are going to use, that will direct assembler to define, to reserve 10-byte of memory location. So in all, we started from DB. So DB means define word. DB means define byte. DW stands for define word, and then DD stands for define double word, DQ stands for define quad word, and DT stands for define 10-byte. So these all assembler directives are being used to allocate the specified memory location in the entire memory map, and the whatever value is going to be there in the assembler directives, that is going to be assigned, that will be assigned to that respective variable. Then the next assembler directive, EXTRN, external. So external, it tells assembler that the names or labels following the directives are in some other assembly module. What does this mean? Like, let me tell you the example first. EXTERN, temperature word, or EXTERN, temperature font. What does this mean? It tells assembler that the names or labels following the assembler directives are in some other assembly module. You can see this word. Like sometimes what happens, like you can have, as far as assembly program is concerned, you can have subprogram or subroutine, right? We call it a subroutine. Let us say we have got in one main program, we have got 10 different subroutine, right? And you can call these 10 different subroutines. One subroutine can be for addition, other can be subtraction, third can be for multiplication, and so on and so forth. For different purpose, we can write, we call it as submodules or a subroutine, right? Sometimes what happens, once you declare this EXTERN temperature in main program, main assembly language program, then you will be free to use this variable in any one of the submodules. Okay, so but only what you have to do, you have to declare this with by using this assembler directive EXTERN. Once you declare this, it means you are free to use this in any assembly module. Okay, as I mentioned earlier, assembly module means subroutine. Otherwise, what you have to do, you have to define those variables in the respective subroutines. You have to declare those. But this is the facility. If you declare this variable with EXTERN assembler directives, then that will allow you to make use of that variables in any one of the subroutine. Now, next is public. What is public? It informs the assembler that defined name or label can be accessed from other program modules. It informs the assembler that defined name or label can be accessed from other program modules. For example, public temperature 1, temperature 2. It means like if you are having main program and 10 different subprograms, main program and 10 subprogram, and if you declare this once like temperature 1 or temperature 2 with public, it means that this can be used anywhere as per your requirement, either in the main program or in the subprogram. Similarly, we have got global and public effect is same. Global and public is, that is why we call it, nowadays we are always referring as a, this is the globalization period. Globalization period means we always refer that now during this entire word is global village. Entire word is global village. It means you can have access to anybody. Let us say by sitting at Aurangabad, you can have access to any universities in US, any universities in UK. You can visit the universities. You can have the online lectures nowadays because of the pandemic across the country, across the globe. Online lectures are being conducted by the most of the online education is being provided by the most of the universities, right? As a result of that, by sitting at Aurangabad, you can be a student of Stanford University. You can be students at MIT University, because anyway you are not going to go there physically. You can study in online mode. Okay, so like that, public and global is a kind of assembler directives which will be used to ask the assembler, tell the assembler that whatever variables we are using, which can be used anywhere. Now, very soon the program is going to be, I mean, this link is going to be terminated because only 1.5 minutes is left. So you have to again rejoin by using the same link. Another assembler directive is segment. What is segment? It indicates the beginning of logical segment. So logical segment means like in one program, there can be data segment, there can be code segment, there can be stack segment. What does it mean? It means that whatever data item you need to provide for program execution can be placed in the data segment. Whatever instructions HRS instruction that can be you need you which are needed for program execution can be placed in code segment, right? Similarly, if you are having stack segment, if you want to use stack memory, then those instruction stack segment related instruction can be used in stack segment, right? So whenever you are using that kind of segment in program, then you need to indicate the start. Okay, the segment is the assembler directive which is going to be useful for indicating the beginning of the logical segment. Okay, I can tell you the example. Here it is not mentioned, but I will tell you later the example. Okay, and S is, it informs assembler the end of the segment.